What really drives academic success? Let's model it. Is GPA just about test scores? Or does it have more to do with where a student lives, whether they get support, or what kind of background they come from? In this demo, we'll use multiple linear regression to build a model of student success, looking at how different academic, demographic, and support variables combine to predict first-year GPA. Our research question is, how do academic preparedness, student demographics, academic activity, and living status relate to a student's first-year GPA? We're asking, which variables matter most? How do they interact in a multivariate model? And how much variation in GPA can we explain with what we know about each student? This is a classic use case for multiple linear regression. Here's why. Our outcome variable is continuous. First-year GPA. We have multiple predictors, including academic preparedness, like a CT math score. Demographics, like gender, age, in-state status. Academic engagement, like tutoring, SI attendance. Living status, on versus off campus. Some predictors are continuous, others are categorical. Multiple linear regression allows us to estimate the unique effect of each variable, holding the others constant. Assess the overall fit of the model. Predict outcomes for new cases. And if you're thinking about using this test in a formal research project, here's a full walkthrough of the study design you'd want to document. Start with your research question and hypotheses. Then we want to define your variables clearly. What's the outcome? What's the grouping variable? And how are they coded? From here, describe your data preparation steps, including how you filtered, recoded, and structured the data. Next, want to explain the method you're using and how you calculated or entered group proportions. We should also mention any assumptions you checked. And finally, report and interpret your test results, ideally with the comparison, test statistic, p-value, and what it means in context. We should also have a model evaluation, then the interpretation of our output. At the conclusion, we should include implications of this model, as well as the limitations of our execution. This structure turns a simple test into a publishable mini-study. Here's what multiple regression gives us. A coefficient for each predictor, how much GPA is expected to change with a one-unit change in that variable, a p-value for each predictor, testing whether its effect is significant, an R-squared value, which tells us how much of the variation in GPA we're explaining with the model, an F-test for overall model significance. Regression answers for us. Which variables are significant predictors? How much does GPA change for a one-unit change in each predictor? How well does the model explain the outcome overall? We'll focus on p-values for statistical significance, coefficients for direction and strength, R-squared to see how much GPA variance the model captures. So we can say things like, after controlling for ACT score and demographics, tutoring still has a significant positive effect on GPA. To run a multiple linear regression in SPSS, we execute on the following process. SPSS will provide a model summary, R and R-squared, analysis of variance table for overall fit, coefficients for each predictor, significance test for each variable. To demonstrate, let's go to Analyze, then Regression, and click Linear as your final step. Set GPA as the dependent variable. Select all relevant predictors, ACT scores, tutoring, age, gender, living status, and so on, and move them into the independent variables box, and I will walk each according to how we have them in the design. First, for organization purposes, we will do academic preparedness, which is all of our ACT scores. We will also classify undecided major status into preparedness. Then to demographics, we have gender, which is a binary variable for male for ease of use, age, and in-state residency, and legacy status. Now to living status, we have on-campus variable, and we will add whether the student has a job. And finally, to academic activity, we will add use of tutoring services, attending supplemental instruction, and membership in a fraternity or sorority. Next, we will click Statistics and check collinearity diagnostics. Click OK. Here's what we found. First, let's look to our model summary. We see our R-square is 0.249, with an adjusted at 0.242. This means that our model explains about 24.4% of the variation in GPA. a fairly solid result given how many other factors influence academic success. And the overall model is statistically significant, with an F statistic of 42.24 and p-value below 0.001. Now to the coefficient output. We first look to the significance report. We see our ACT math is statistically significant because the p-value is below 0.05, as is ACT science. That said, ACT English and reading are not. Being an undecided major is statistically significant. Now to our demographic factors. Being a male is statistically significant. Age is not a statistically significant factor. State residency is statistically significant. And legacy status is nowhere close to significant. Living on campus, our only living factor, is not statistically significant. But having a job is statistically significant. Finally, using supplemental instruction is the only statistically significant factor of all academic activities. Now let's interpret what we can take away from our statistically significant variables. Overall, we take away that students with higher math as well as science scores had higher GPAs. For every 1 point increase in math yields about a half point in GPA, which is twice the impact of science, which only accounts for a quarter of a point per increase in science score. And undecided majors have about a 0.2 point lower mean GPA, all other things held constant. Males have nearly a half point lower GPA when rounding up, albeit fairly aggressively. This is significant. Those out of state are about 0.12 points higher. Interestingly, those employed by the school appear to imply greater academic discipline, as having a job on campus yields a roughly 0.3 of a point higher GPA. And using supplemental instruction yields about 0.4 of a point increase in GPA. So the big takeaways are that attending SI and working on campus were both strong, positive predictors. Being male and in-state were associated with lower GPAs on average. Math and science scores had a small but significant effect. Interestingly, ACT English and reading, age, and even living on campus weren't significant predictors in this model. Now let's quickly go over to our collinearity diagnostics. We see all variables are well below 2 in terms of their variance inflation, or the variance inflation factor, with the exception of ACT math scores, suggesting that adding all ACT scores is likely redundant. The following is a rule of thumb when evaluating the collinearity of variables in a regression model. That's multiple regression in action, letting us ask, which variables matter most, and how do they work together to predict GPA? In future videos, we'll look at adding interaction terms, testing assumptions, and even comparing models. Subscribe, and as always, stay curious.